seekers of truth. We will look at one more example here of how to find the range. And this example is a good illustration of some of the difficulties of finding range, because in this example I'll show you why the graphical solution works and the algebraic solution does not work. Right? So let me show you the correct solution, and then we'll talk about why solving this algebraically doesn't work. So to graph this, instead of graphing square root of x plus 5, let us start out by graphing something a little bit more familiar if we just graph the square root of x. So the square root of x looks something like this. It's some people describe it as a shooting star, right? It's going to go through 0, 0. And the range of this is going to be, let's see, the range of this is going to be from 0 to positive infinity. I mean, that's pretty straightforward. Whatever numbers you put in here, you're always going to get out either 0 or a positive number. And then now, let's actually graph our solution, our function here, h of x. Well, that's the same thing as the square root of x, except everything's moved up by 5 units. So it's going to look something like this. Right? If you put in 0, instead of getting 0, you're going to get 5. And any number you put in here for x, you get the square root of that, and you add 5 to it. So it looks like this. And so the range, the answer to this, so this is h of x, just to be clear, and the range, or the answer to this question is quite simple. It's closed interval from 5 to positive infinity. So that's actually the correct answer. The graph confirms it. Now, it's worthwhile to actually look at a wrong answer. Some of the other methods that we use, the algebraic methods, is, let's just solve for x and see what's going on here. So if you were to do this, you would say y minus 5 would be equal to the square root of x, and then you would square both sides. And to get x by itself, we would square both sides, so we would get y minus 5 quantity squared is equal to x. And we would think that all real numbers should work, right? That all real numbers should be part of the range, but clearly it's not. So this is an example where the algebraic solution can actually lead you astray. In the next set of videos, we'll look at some examples of where the graphical solution can lead you astray. So the moral here, the main idea here is always confirm algebraically and graphically when you're finding the range. So let me emphasize this, because I can't quite emphasize it enough. When finding range, you need to use both the graphical and algebraic methods. There's really no other way to get around it. And in the next couple videos, I'll show you why this is pretty complicated. Okay? So always use both the graphical and the algebraic methods when you're finding the range. If you use just one, it'll work some of the time, and then it'll fail dramatically some other times as well. So let me just clarify one more time that this is the incorrect solution, even though algebraically it works out, but you really need to confirm both ways. As we progress along in this class and you study a little bit more higher level mathematics, we'll resolve these issues and see why is it that algebraic and graphical methods don't always agree. So correct answer is 5 to positive infinity. Main idea, you want to use both graphical and algebraic methods, and one of them should confirm the other, otherwise one of them is incorrect. All right, as always, keep working hard, keep thinking hard. Thank you for watching, and have a wonderful